Hey Josh. So I'm making a video to kind of try to explain where we erred on that one problem. I tilt the camera this way just so you can see the board a bit better. So I recreated the problem here. They gave us f of x is square root x, c equals 1, L equals 1, epsilon equals a fourth, and as always we're trying to solve for delta. So our first step was correct. So we fill in the basic equations. So you can see I've taken absolute value of f of x minus L is less than epsilon, and absolute value of x minus c is less than delta. And then I just kind of plugged in everything. So my two final equations were absolute value of square root x minus 1 is less than a fourth, and absolute value of x minus 1 is less than delta. Now, after that, we're supposed to try to manipulate the epsilon equation, so that's the first one, to look like the delta equation. So where we erred is, and this is something that I think people learned very early in algebra, which is why we forgot, but we can't manipulate this equation to solve for x until we get rid of the absolute value. And so the way that you do that, so if you have a statement that says absolute value of radical x minus 1 is less than a fourth, remember what the absolute value means is the distance is a fourth in both the left and right direction. So what you can do is in place of this 0, put a negative 1/4. And so the absolute value is now accounted for because you've now placed a fourth on both sides. Once you've removed the absolute value, you can then proceed to solve for x. So I added 1 to both sides to get this, then I squared both sides, and then I subtracted 1 because remember our delta equation was absolute value of x minus 1 is less than delta. So I ultimately, remember, wanted these two things to look as similar to each other as possible. And so then our last step was correct. We would compare the two equations. Now, this is kind of where things got a little bit confusing because normally, at least in AP or BC calculus, both sides of the equation would be the same in the sense that you would have equal distance on both sides, and so there would be no confusion or ambiguity. But here, essentially, as with the graph, we know the answer is 7/16. You essentially want to pick whichever is the smaller of the two numbers. So we can see that that is how we get that answer from the graph of 7/16. So I know that's a bit confusing, so I kind of tried to do a second whiteboard here just to explain how the absolute value works. So here I have a number line with 1 in the middle. And so if I want to go a distance of 1/4 to the right or 1/4 to the left, there are two ways to represent that information. The first is with an absolute value symbol. So we say absolute value of x minus 1 is less than a fourth. So what that tells you is the distance from x to 1 is a fourth. But the other way to explain that without using absolute value is to simply say x minus 1 is less than a fourth, but bigger than negative 1/4. So that is the technique that we're using in these types of problems to get rid of the absolute value so that we can manipulate the equation to solve for x or whatever we need to. So that is the technique that I used up here to get rid of the absolute value. Again, this is something that, so my textbook as well as Khan Academy and some things skip over a lot of these steps, which is why I think we didn't notice it, but we do have to get rid of that absolute value in order to manipulate the equation. So that is why, before we ended up with just 9/16, but here you can see that we have a 7/16 and a 9/16, and as with the graph, you want to pick the smaller of those two deltas because otherwise you will be outside of the interval on one side. So I'm going to send this along with the Khan Academy video. We can talk about it some more next week. Hopefully this helps a bit. Everything else we did was correct. It's just when we were doing these manipulations, we should have gotten rid of the absolute value by essentially breaking this up on both sides. So instead of it being 0 and a fourth, we get rid of the absolute value and we do a fourth and negative 1/4. All right, signing off. Good luck.